All right, this is part one of our quadratic applications lesson. We will be given word problems and we will set them up and then use one of our solving methods for quadratics. We have factoring, square root property, completing the square, or actually this one we haven't learned, or quadratic formula. So there is a 7-step strategy here for solving problems, and I'm going to go through those steps one at a time as I work these. So in this first problem, we have this category called consecutive integers. And this first problem says the product of two consecutive odd integers is 195. Find the integers. So step one of the strategy says to read the problem, make sure all the words and ideas are understood. So we're going to do that first. So by product, we mean things that are being multiplied. So we mean multiply. This word consecutive means things that are back to back. Odd means odd numbers. Integers is the set of positive and negative whole numbers. So 2, 3, 4, 5, or -2, -3, -4. It does not include fractions, decimals, or radicals that don't simplify. So positive and negative whole numbers. So that's step one. Step two, identify what we're looking for. That comes from this sentence right here. This word find says find the integers. So that's what we're looking for. Step three is to name what we're looking for and choose a variable. So I have two integers, a first one and then a second one that comes next. I'm just going to give them variables x and y. Step four says translate into an equation. It may be helpful to restate the problem in one sentence with all the important information, then translate the English sentence into an algebraic equation. So the way I'm going to do that here is I know that the product of the two consecutive integers is 195, or when I multiply them, I get 195. So I'm going to set up this equation. X times y is 195. Now, I run into a problem where I can't solve yet because I have two variables. And even if I were to divide both sides by y or x, I would still have a variable on the right side and I wouldn't be able to figure out the number. And something we learned in previous math courses and this one is this. If you have two different variables, you're going to need two equations to solve for them. If you have three variables, you're going to need three equations, so forth and so on. So our goal here is to get a second equation. And the information that's going to come from is this idea of consecutive odd integers. So consecutive means back to back. If I have odd numbers that are back to back, like let's say I have 7, 9, 11, 13, mathematically how I get from 7 to 9 is I add 2. How I get from 9 to 11 is I add 2. So if I have these two variables, x and y, x is the first one and y is the second, and they're both odd and consecutive. How do I get from x to y? I add 2 to the first one. So x plus 2 equals y. So now I have two equations and I have two variables. And earlier in the year, so this is called a system of equations. And earlier when we solved these, we did three different methods. We did graphing, where we found their we graphed them and found their intersection point. We did elimination, where we eliminated one of the variables by having opposite numbers in front, like a -3x and a +3x cancels out. And we did substitution. And this is a perfect setup for substitution because the second equation is solved for one of the variables already. Y equals x plus 2. So if y equals all of this, these are equivalent things. They can substitute for each other. So if y equals x plus 2, then in this other equation where I see a y, I can replace it with the x plus 2. So that's going to give me the x from the original equation. Now instead of times y, I'm going to have times x plus 2. And I'm putting those in parentheses because they're grouped together with the addition. And that equals 195. So now I have one equation with one variable, and I'm going to solve it. I start by distributing my x. I subtract the 195. Now I'm going to factor this trinomial using my cross. What multiplies to negative 195 and adds to 2, and the answer is 15 and negative 13. So I'm factored. I set my factors equal to 0. This is our zero product property. And solve them. So x equals negative 15, x equals positive 13. Now these aren't my answers because these aren't consecutive numbers. Negative 15 and positive 13 are not back to back. So what I'm going to do is go back to my original setup here, and I said that y, which stands for my second integer, we get it by taking our x and adding 2. So if I have x as a negative 15, then my y is negative 15 plus 2, or negative 13. And if I have x equals 13, and I add 2 to that from my y, I have positive 15. So what's happening here is I actually have two sets of answers. Because negative 15 times negative 13, their product is positive 195. Positive 13 and positive 15, their product multiplied also 195. So I want you to pause the video, and I want you to turn to the back and try number 2 by yourself. All right, here's my number 2. If you need to pause the video to compare yours to mine, go ahead and do so. And then take a minute and pause the video anyway and read the next problem before we get started. All right, this next section is geometric applications. Mike wants to put 150 square feet of artificial turf in his front yard. It's going to be the shape of a rectangle with length 1 foot less than 3 times the width. And then we're being asked to find the length and width. So there's our step that's telling us what we're looking for, so we can use that to identify our variables. I also like to draw a picture sometimes. Remember that area is length times width. Length is the long side, width is the short. This is my rectangle. Let's just let L equal length and W equal width. Now this 150 square feet number, that is talking about my area. And I know that the area of a rectangle is length times width. So I can put that 150 in for my A. Now I'm kind of stuck here just like I was in the last problem, that with two variables I need two equations. So my second equation is going to come from this phrase right here. The length is 1 foot less than 3 times the width. So the length is 1 foot less than, that means I'm going to subtract 1 from 3 times the width, and the width was W. So the length is equal to 1 less than 3 times the width. So now I can set this up the way I did the last problem. L equals 3W minus 1. And I'm going to plug it into the other equation for L. So that gives me 150 equals 3W minus 1 times W. So I distribute the W. So 150 equals 3W squared minus W. Subtract 150 to both sides. Now 0 equals 3W squared minus W minus 150. So now that this A value up front is a 3. We would probably try and slide and divide here. So let me set that up. And then we would ask ourselves what multiplies to negative 450 and adds to negative 1. And after some trial and error, you find that nothing works. So this can't factor. That doesn't mean we can't solve it. It just means we can't solve it by factoring. So what I'm going to do is go back to this equation here on this step before I tried slide and divide. And I'm going to do quadratic formula with that. So coming over here, I'm going to identify my A, B, and C values. So A is 3, B is negative 1, and C is negative 150. And I'm just going to plug those into quadratic formula. I'm going to use a red pen to show what I'm substituting in and a black pen to show what the formula is. And I'm solving for W. So W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So if you need to pause your video and make sure your substitution step is good. When I taught the quadratic formula lesson, I said to start with these numbers inside the radical, just kind of bring them out here by themselves and do that math first, following the order of operations. So you do your exponent first. Negative 1 squared means times itself, so positive 1. And now do not do 1 minus 4 next. You're doing multiplications first, left to right. So this one gives me a negative 12. And this one gives me a positive 1800. Now you do the addition and you get 1801. And this is the number you're going to plug back into the radical. So outside the radical, I have this negative 1, which makes positive 1. Inside the radical, I have 1801, and denominator, I have 6. So remember that plus or minus is actually indicating I have two different answers. I have the plus radical version and the minus radical version. And as decimals, this positive version is 7.2, and the negative is negative 6.9. Now you can't have a negative length measure in this situation because it's a physical situation. So that one is not a solution. So my solution for the width is 7.2. But the problem is also asking me to find the length. So if you go back here to this formula, so I'm right here, the length is equal to 3 times the width minus 1. So now I know the width. It's 7.2. So this is going to give me 21.6 minus 20.6. So my length is 20.6 feet. And my width is 7.2 feet. Now you take a minute and try number 4. Pause your video. All right, here is my work. We had a similar situation where I tried coming up with factors that multiply to negative 100 and add to negative 2, and I couldn't. So since I couldn't factor, I used quadratic formula. Notice I pulled a GCF out of 2 here. That's not necessary. You could have used these numbers for your quadratic formula and you'll still get the same answer. So it's not necessary to do GCF, but I did. I have my substituted numbers written in red, and then here's the math for just what's inside the radical. I got 404. Then back up here, I have the positive version of radical 404 and the negative version. The negative gives me a negative number, which I throw out. So my width is 11.0, and then I plug that back into my L formula to get 18 feet for the length.